Okay, welcome to the chemistry class from 5. Today we are going to start a very new topic. It is hybridization. So what is hybridization? Hybridization, it is a process of mixing atomic orbitals to form hybrid orbitals with equal energy and identical shape. So that's the reason why do we mix the atomic orbitals. It's because we want to form the hybrid orbitals, but the hybrid orbitals are orbitals which have equal energy and identical shape. Examples of the orbitals that we can mix are s orbital, p orbital, d orbital, and etc. These are examples of the orbital that we can mix. See, so let's proceed. Wow, those are examples of the orbitals that we can mix. Uh, this one is s orbital. This one is p orbital, and that one is d orbital. See, these are shapes of the orbitals. See, so are the orbitals that we can mix. See, like that. It is further explained here, or further shown here. You can see clearly the diagram of the s orbital. S orbital is circular in shape. This is a p orbital. You see, uh, it is lies along the z-axis, and there you see the d orbital. See, it lies between the z-axis and the x-axis at the same time. So those are shapes of the orbitals. If you are told to draw the shapes of the orbitals, you draw it like this, and you have to show the planes also like that. So those are shapes of the orbitals. Now let us proceed. Orbitals overlap to make hybrid orbital. See, as I've told you that we mix the orbitals in order to form the hybrid orbital. And you see, if we take s orbital, we mix with p orbital, we shall form the sp orbital. See, if you take s orbital, we mix with c2 orbital like this, we shall get sp2 orbital. P square here, it means the two p orbitals were mixed with one s orbital, and if we take one s orbital, we mix with the 3p orbital, we shall get the hybrid orbital, which is sp3 orbital. So these orbitals formed are called hybrid orbitals because are the orbitals obtained after mixing the orbitals there. See, that this that was a further explanation about the hybridization. Hybridization. So the orbitals that we shall obtain after mixing the orbitals are sp orbital, sp square orbital, and sp3 orbital. These are the whole hybrid orbitals. See, orbital obtained after mixing the orbital. See, the orbitals that we shall get are hybrid orbital, as you see there. So depending on the number of orbitals mixed, see, there are four categories of hybridization. See, we have sp3 hybridization, sp3 hybridization, sp2 hybridization, sp hybridization, sp and d hybridization. See, these are types of hybridization, depends on the number of orbitals that are mixed. See, so if you are told to mention the types of hybridization, you'll mention these types of hybridization depending. But sp3, sp2, and sp are very common hybridization. So those are types of hybridization. See, let us see sp3 hybridization. sp3 hybridization is the one whereby one s orbital mixed with 3p orbital to form sp3 hybrid orbital. In that hybridization, we take one s orbital here, we mix with the 3p orbital. But the p orbital that we mix with s are px orbital, py orbital, and pz orbital. When I say px orbital, I mean that the p orbital, it lies along the x plane. If I say py, I mean that the p orbital, it lies along the y plane. We shall see. If I say pz, I mean that the p orbital, it lies along the z plane. Methane, for example, methane, it has sp3 hybrid orbitals. See, formation of methane. See, it involves the sp3 hybrid orbitals. See, let us see here. Oh wow, very good. This is very good example of hybridization or sp3 hybridization. You see here now. Before, this is the carbon atom at the ground state. See, carbon atom at the ground state. At the ground state, the carbon, it had how many p orbitals? It has 2px and 2py c orbitals. But 2pz, it was empty. Do you see there? It is empty. The 2pz is empty. So what do we do? In order to mix s orbital and these p orbitals, first of all, we have to promote the one electron from the s orbital. One electron here is promoted, and after it is promoted, then it will fill this space. See, this electron, after gaining the energy, it will be it get promoted to this space, and then it fills that place. After it fills that place, then the place it becomes filled like this. See, oh wow, now you see. After promoting that electron, then it has filled this place. Now here, all orbitals you see, all orbitals uh, have is acquired by electron, occupied by electron. Now the carbon is at excited state. See, so before hybridization, 2s electron is promoted to an empty 2p orbital. See, that is the first step. So wait to see the next step. The next step